Alright, so in this video, I'm going to show you how you can fill in the Excel spreadsheet where some of the parameters are coming from the case study itself. So those would have been color coded in blue color. The one in yellow would be the decisions that you have to make that is part of evaluating the optimal quantity of potatoes and green beans such that you can minimize the total cost, which is the goal of the case study. All right. So without further ado, let's focus on the first item, which is the unit cost per pound. So just a gentle reminder that I'm using pound as the baseline weight for comparison, and to ensure consistency, you have to make sure that the nutritional benefit coming from each of the commodity in terms of protein, iron, vitamin has to be measured from the baseline weight, which is the pound. All right. Not to forget this total weight. Again, it must be based on pound, so on and so forth. So consistency is one of the key things, right? I think we'll just fill in the unit cost as a start, whereby from the case itself, you can easily pick out from the cost of potato per pound is 40 cents, and for the green bean is going to be $1. The difficult and more challenging aspect of the problem comes from the nutritional benefit generated by, let's say, the potato for the protein, right? Over here on the right hand side, you'll notice this very familiar table that's been given to you again from the case study itself, that this is what you can search online, and obviously they are not converted into the base unit, the base weight, which is pound, because right now what this information is showing is that all the benefit, the nutritional benefit for protein, iron, and vitamin C are based on the weight per 100 gram of the potato. So for every 100 grams of the potato, you're going to get respectively 1.5 gram of protein, 0.3 mg of iron, and 12 milligram of vitamin C. So then the question is, how can I actually convert from where when we're looking at 100 grams of potato, how can I then view this information when it's based on 1 pound of potato, right? So it makes sense for us to make this conversion, and there are some pretty key information about how you can make the conversion. For example, it is to be noted that there are 453.569 gram in 1 pound. So in order for you to view this information from 1 pound perspective, so what you need to do is just to, again, let's take the example of a protein, which is 1.5 grams per 100 grams of which is coming from, well, just 100 gram of potato. But because I'm interested to look from 1 pound perspective, this is the conversion that I'm supposed to be doing. So then in this way, I can actually look at what's the contribution of potato for proteins from a pound perspective. All right, so all I need you to do is just to focus on the denominator, because just to recall that 100 grams time 4.53569 will give you £1. All right, so that's how you actually make the conversion. So in this case, what I'm going to do is simply just multiply 4.53569 multiplied by 1.5. All right, we're going to do the same thing for the rest of the other nutrition or the benefit generated by £1 of potato. So 0.3 times 4.53569, and the oops, I should have an equal sign over here. All right, and the last item would be 12 milligram. All right, multiplied by 4.53569. The same thing goes for the green bean as well. I mean, in a very, very similar way. Again, because the green bean is viewed from a 10 ounces perspective, and we have to make sure that we're consistent with looking at it from £1 perspective, and that conversion is equally familiar. So all you need to do is just to make sure that you're going to find the numerator and denominator to be the same number, which in this case, instead of 4.53569, we're actually using 1.6. And the reason is very simple, because the moment when you look at the denominator, all right, what we're saying is that, well, actually 16 ounces, all right, is equivalent to £1. So in order to make this conversion, all you need to do is just to multiply by 1.6. All right, so how do I get 16? So in this case, again, this information is coming from the case itself. So 28.35 grams in 1 ounce, 453.569 gram in £1, and therefore we have 16 ounces in £1. All right, so this is exactly how you make the conversion. All right, and so in this case, I'm going to just simply multiply by 1.6 in the numerator, multiply by 5.67. All right, so let me just multiply by 5.67, and then the next thing is 3.40 through multiplied by 1.6, and the last item would be 28.35 times 1.6. All right, so we're almost done. All right, in this case, then we have completely filled up the nutritional benefit generated as a result of £1 for each commodity. All right, the next item is actually the nutritional requirement, because again, if we look at individual nutrition, then it's actually given to us in for example, the protein is saying that, well, the university has established this minimum requirement of the dish must provide at least 180 grams of protein, right? So then 180 grams, and then we have 80 milligrams, and finally we have 1050 milligrams for the vitamin C, right? So as a requirement from the university. And of course, the other item would be converting the target, which is set by Maria, all right, who is the manager of the cafeteria. And this was meant to satisfy the demand requirement based on the population of the student in the university. So in this case, the target was meant to be 10 kilograms, and because we're looking at how many pounds is that, so you need to make the conversion of 10,000 divided by 453,569, right, to give you this target in terms of pound. And the last item is actually the taste constraint, which is recommended by the chef Edson Brenner. He recommended that the weight of the potato over the bean should be at least 6/5, which basically convert into 5 times potato must be at least greater than or equal to 6 times bean. So basically it's just 5 times potato must be at least greater than or equals to 6 times the bean. So we're pretty much done in terms of populating our spreadsheet. But obviously, I will invite you to go and look at the individual formula. So to do that, you can actually look at, say, for example, how do you evaluate the total cost, which is based on the unit cost and the quantity. All right. So the number of the quantity of potatoes times the unit cost plus the quantity of green beans times the unit cost, and everything is measured in pounds. All right. But another example would be, say, the benefit, which is the nutrition that's generated across all product, all right, which is potato and green bean. So in this case, we have again the quantity for each item multiplied by, well, the amount of benefit generated by each item multiplied by their respective quantities, right? So just take note of that, and I'll leave the exercise to you. So I think we're almost ready to solve this problem based on, well, using the solver to map out the various part of the decision-oriented problem. So we always go to the data, and then on the extreme right-hand side, you'll see the solver popping up. And so let me just very quickly go through how do you do the mapping exercise. So for instance, the objective function is basically the total cost that's coming from the orange cell. And because we are interested to minimize the cost, so just make sure that you will use the correct operator. All right, so it's not maximum, so you have to choose minimum. Changing cell always excuse me, refer to the decision. So in this case, it's going to be the quantity of the potatoes and the green beans. All right, and then you have the few constraints that you have to satisfy. So the first constraint, let me again just show you exactly where they are being mapped in the spreadsheet. So let's look at the first one. In this case, we're looking at the taste constraint. All right, so this would be the total weight of the potato based on, again, the decision and the recommended multiplier which must be at least greater than or equals to the bean ratio, which is actually this part of the spreadsheet. All right, so let me just be clear. So you see that this is the part of the spreadsheet that gets highlighted. All right, so the next item is actually the nutrition requirements set by the university. Again, if I actually choose change, then you'll be able to see that it's actually mapping, all right, the cell reference coming from the total nutrition generated across the commodity for each item, which must be at least greater than or equal to the corresponding nutrition requirement, which is again the rule set by the university. All right, so if you're happy with that, just go out, and the final item or the constraint is actually the target weight of the casserole that must be produced, all right, on a weekly basis. So in this case, again, we're actually looking at the total weight that's evaluated from the casserole, which consists of the potatoes and the green bean, that must provide a minimum weight. So that would be communicated by, again, the correct inequality must be at least greater than or equals to the minimum weight or target set by the cafeteria manager who is interested to minimize the cost, right? So with that, we have three sets of constraint that's being added into the solver. And of course, just to make sure that you have to check this to ensure that you don't get negative values on your decision, because we're not so interested in backlogging. All right, we're not interested in owing quantities, so there's no negative numbers. And the solving method is always simplex LP by default. And once you're happy, just solve this problem. But before solving it, I'll just quickly want to show you the sensitivity report, which you can actually pull from the solver. All right, so just click on the second item and click OK. But before you click OK, I just want to make sure that you're aware there is actually no sensitivity report at this moment, because the moment once you click OK, something pops out and this is what you get. All right, but before that, let me just go back to the solution itself. So the Excel solver is suggesting that we have 13.57 pound of the potato and 11.31 pound of green bean to make the casserole. And obviously it's satisfied constraint, and the minimum cost achieved in this case is going to be 16.73. So again, just to give you a sense of why, as a follow-up on the case itself, Maria is actually looking at other options, which include modifying the taste parameter and also the iron nutrition as well. So it comes from the shadow price, all right? So you realize that the rest of the other items have zero shadow price. And again, just a gentle reminder of what shadow price does in the case of a minimization problem is that in order to reduce your cost, because we are trying to minimize cost, you have to give up some kind of, let's say, a benefit, all right? So let's say from the shadow price itself, I would think that relatively speaking, between modifying the iron requirement versus the potato, or rather the taste requirement, it seems to me like the iron requirement is a much better deal, because you can actually save a lot more. Well, I guess 10 times more, almost 10 times more. Let's just by modifying the iron constraint. So again, in this example, what we're saying is that in order to save 20 cents or 21 cents more, you will have to reduce your iron requirement by a unit of 1. And this allowable decrease gives you the lower bound in which you can actually reduce until, all right, you're going to generate more and more benefit, or in terms of cost savings, by relaxing your requirement. By the same time, there's always a limit in terms of how much you can actually realize that reduction. So let me just quickly give you a sense of what's going on here. So it basically says that, well, if I'm actually trying to cut my costs by relaxing the iron nutritional requirement, then the best that I can go down to before no changes would ever happen is actually 73.89 gram. All right, so what that means is, say for example, if I relax, go back to the problem again. Now the requirement is 80, so if I change this to 79, then I'm going to generate a benefit of cost cutting by I think at least 21 cents. So in this case, it's going to be equals to 16.73 minus 0.21, which is equals to 16.52. All right, so let's see what happens if I actually relax this constraint by 1 unit down. All right, so I'm going to solve this again, and right, so you're going to see that the numbers actually match up on my prediction that if I actually now reduce my requirement down to 79, then I'm going to get a reduction of 21 cents down from the previous model. All right, so then again, coming back to the sensitivity report, so this is saying that, well, if I'm going to reduce down continuously, it's not forever that I can always generate all the benefit. There's a limit to it, and the best I can reduce down to and still obtaining that 21 cents reduction, it will be only down to 74. So you might imagine that the 65 as suggested by Maria, all right, there was this next option of lowering the iron requirement down to 65 is actually a lot aggressive, and it might not produce the necessary benefit per what is suggested by the shadow price itself. All right, so that's the high level insights